What is up, guys? So today we have a geometry challenge problem, which basically says find the area of the square inside the right triangle if the legs are each 6. So we can just call it 6 units. We're not given a measurement. So we want to find the area of this square that is inside of this triangle. So first, what are we given? So we know that this has a 45-degree angle, 90-degree angle, and 45-degree angle. And these two lengths are the same, which means that this big main triangle is isosceles. So step 1, we found that it's a big isosceles triangle. So what's our next step? So we're given that this is a 45-degree angle, and we know that this is a square, which means that all of these angles are 90 degrees. And if you know what a supplementary angles are, you'll know that two angles have to add up to 180. So this is 90, that means this also has to be 90, because 90 plus 90 is 180. So we have 45, 90, and so what is this angle of triangle A? I just went ahead and labeled it. So 45 and 90. So 45 plus 90 is equal to 5, 9, 10, 11, 12, 13. And we know from previous knowledge that the angles in a triangle equal 180. So 180 minus 135 is equal to what? 45. So that means that this angle here is also 45. So we have another isosceles triangle. So triangle A, which is this that I've labeled, is isosceles. And we can use the same concepts over here in triangle B, which makes triangle B isosceles as well. Alright, so this means that both of these legs are equal. And since this is a square, that means all of these legs are equal. So that means this leg has to be equal to this leg. And since this is isosceles, you have boom, boom, boom. So as you see, we have 1, 2, 3, 4, 5, 6. 6 legs are all the same. And you can see what we've actually done is we've broken down this hypotenuse into thirds. So now we want to find this hypotenuse. So step 3, hypotenuse. Alright, so if you know the hypotenuse rules for isosceles triangles, I'm just going to break it down too. So the isosceles rule for hypotenuse is basically x, which is these lengths, one of them, times square root of 2. So x times square root of 2, which means that our hypotenuse of this big main triangle is 6 times the square root of 2. And so as I mentioned a couple of seconds earlier, these are all equal to each other. And so we've broken down this hypotenuse into thirds, which means we can divide this number by 3 to find each single length. So 6 times the square root of 2 over 3 is equal to what? I'll give you a couple seconds. So it's equal to 2 times the square root of 2, because if we simplify, you have 1 and then 2 and then boom. I'm sure you know that. So now this means that this length of the square is 2 times the square root of 2, because all of these are equal. So if you know one, you know all of them. And so let's go back to what we really want to find, the area of the square. So we know that all lengths of the sides of the squares of the square is the same. So let's just draw out the square here. And we have that which means we also have this, which means we also have this, which means we also have this. And so this is step 4. And I'm sure you know how to solve the area of the square. But if you don't, it's one side times the other side. So we have 2 square root of 2 times 2 square root of 2. I'm just going to draw a line to separate it. So when we multiply it, what do we get? Okay, so we have 4 because 2 times 2 is 4. And then we multiply these square roots together to get the square root of 4. So when we do that, I'm just going to bring this up over here. 4 times the square root of 4. The square root of 4 is what? So if you know your maths, you'll know that the square root of 4 is 2. So that means 4 times the square root of 4, which is 2, which makes our answer 8. So the area of this square is 8 units.